Hey everyone, welcome to a brand new explainer. Today, we are decoding the invisible grid that surrounds us every single day. We're diving straight into Chapter 8 of our English mathematics curriculum to totally master the concept of directions. We're going to figure out exactly how to orient ourselves in the physical world, moving from a deep understanding of spatial awareness to identifying how the very spaces around us are engineered. Whether you're outside looking up at the sky or just inside looking at the furniture in your living room, this explainer is going to completely change how you see your surroundings.
Here is our map for today's journey. 1. Finding your way. 2. The 4 main directions. 3. Exploring subdirections. 4. Navigating the classroom. 5. Horizontal and vertical. And 6. Measuring our world. Let's get right into it.
Section 1. Finding your way. Situating ourselves in the wider world.
Okay, imagine this scenario. You're far from home, your phone battery is completely dead, and you don't have a compass anywhere on you. You're just standing in a vast open field. How would you figure out which way you're actually facing? It's a pretty profound puzzle, right? But it's one that humans have solved for literally thousands of years. Long before we had magnetic compasses or GPS satellites, ancient explorers and mariners were successfully mapping entire continents. And their secret? Well, it wasn't technology. It was a deep reliance on the absolute most consistent natural indicator we have in our sky, the sun.
Section 2. The 4 main directions, the foundation of orientation.
You've got to appreciate the sheer elegance of natural navigation here. Picture a person standing with their arms outstretched, looking directly at the sunrise. Because the sun reliably comes up in the east, the moment you align yourself with that morning sun, boom, you've established your entire compass grid. By simply facing east, the west is firmly locked right behind you, north perfectly aligns to your left side, and south aligns to your right. This is an absolute rule of our planet's rotation. It essentially means that as long as you know where the sun comes up, you hold the key to mapping the entire world around you, exactly like our ancestors did.
Section 3. Exploring subdirections, the spaces in between.
Now, the crucial point here is that we often need a bit more precision than just those 4 primary pillars. Life and geography rarely move in perfect right angles, do they? So this is where subdirections come into play. Geometrically, we just take the exact right angle between 2 main directions, let's say north and east, and we divide it exactly in 2. That precise 45-degree middle path, that gives us northeast. And by doing this all the way around our compass, we generate southeast, southwest, and northwest. This isn't just some abstract theory either. It's literally shaped human history. Famous trade routes, massive weather systems like a powerful nor'easter storm, they rely entirely on these specific subdirectional vectors. So, together with our 4 main points, we now have this incredibly precise 8-direction system to pinpoint absolutely any location.
Section 4. Navigating the classroom, shrinking our focus.
All right, let's bring this grand global concept down to a much more familiar scale. I want you to picture a typical classroom. If you were standing right at the teacher's table in the center of the room and you needed to tell someone exactly where the blackboard or the windows were, how would you do it? Take a quick second to mentally place yourself in that room, orient yourself, and think about how you'd use our new compass rules to give flawless directions.
Okay, so let's map it out. Assuming our compass shows north pointing toward the top, let's make that teacher's table our center point. From this specific origin, the blackboard is positioned squarely to the north of the table. If we turn to our right, looking east, we see the window letting in all that morning light. Over to the west, we have the wooden cupboard for storage, and down to the south, directly facing the teacher's table, sits the student's desk. It's just a perfect, practical micro-application of the exact same macro rules that sailors use to navigate the oceans.
Section 5. Horizontal and vertical. How our world is built.
So, to accurately describe the location and physical structure of an object, we use 2 fundamental geometric concepts. First up, we have the horizontal plane. Think of the surface of water in a large basin when it is completely still. It's perfectly flat, right? Not inclined in any direction whatsoever. And the reason it behaves this way is actually a profound physical truth. Earth's gravitational pull forces liquids into a state of equilibrium. That means a horizontal plane is literally defined by gravity. On the flip side, we have the vertical. This is straight up and down, perfectly perpendicular to that flat horizontal waterline, kind of like a wall standing rigidly straight up from the floor.
Let's look at how this physical reality is actually built into the everyday objects we use. Take a standard table, for instance. That flat wooden surface where you place your books and rest your arms, that relies entirely on a stable horizontal plane, so your things don't just roll off. Now think about a typical chair. While the seat you rest on is horizontal, the sturdy backrest that supports your posture, and the 4 legs holding the whole shebang up against gravity, those are all vertical planes. Every single piece of furniture, every room, and every towering skyscraper you ever interact with is basically a carefully constructed architectural puzzle of horizontal and vertical lines.
Section 6. Measuring our world. Tools of the trade. Now think about the brilliant yet beautifully simple tools that builders use to measure these exact planes. First, there's a spirit level. It uses a tiny air bubble trapped in liquid inside a small vial. When that little bubble rests exactly in the center between 2 painted lines, you know mathematically that your surface is perfectly horizontal. Then we have what's called a plumb, basically a heavy weight hanging free from a string, often placed against something like a door frame. Gravity ensures that the string hangs in a flawlessly straight vertical line downward. And honestly, perhaps the most fascinating one is just a transparent tube filled with water. Builders use this as a water level to see whether 2 points, which might be really far apart on a construction site, are at the exact same horizontal elevation. And get this, it isn't just a modern trick. Ancient civilizations, like the Egyptians, actually used variations of this exact water leveling method to build the flawlessly flat, sprawling foundations of the Great Pyramids. Pretty wild, right?
So we've gone from using the sunrise to define the east, all the way to understanding the exact vertical drop of a builder's plumb line. My final challenge to you is this. Look around the room you are sitting in right this very second. Can you point to a perfect horizontal surface and a perfect vertical surface? And if you absolutely had to, could you tell me which one is to the north? Keep looking at the world this way, and I promise you you'll never be truly lost again. Thanks so much for joining me on this explainer, and keep exploring.